So in this video I'd like to go through how we resolve the two issues that we didn't have time to cover in the last session. For this purpose we're going to be doing a little bit of scripting again. There's nothing super complex involved, but you might want to do a refresher of part 3 if you have trouble following along with some of the concepts today. Alternatively, you can watch through to the end of this video, and then once you see how it all comes together, then you can re-watch the parts that you find challenging. So I always find it much easier to see how everything works once the end result is clear. I will try and explain everything in detail as I go through it, but as always, feel free to leave a comment or send me a message directly if something is confusing or unclear. Alright, so let's dive back in. Last we left off, we had a couple of major gaps left to bridge in this conversation. So the first one is the easiest to fix, and that's where we start. That's going to be our alignment shift. If we head back over to our conversation window and look for the node in which the alignment shift happens, we'll see that there are a few options that can be applied to this specific node. A couple of them we've already used, namely the text appears when. That's for trying to decide which particular dialog option is displayed, and other actions, and that was used for adding our journal entry. Here instead we're going to use the Actions Taken tab. Actions Taken is exactly what it says on the tin, so after this node runs, you execute the attached script, so you take that action. And this seems like the thing that we want to do for our purposes. For now, let's click on the edit button, and that will fill in the blank script there, create a brand new script window for us. So now there's a little mini challenge if you're feeling confident about the scripting. What we'd like this script to do is just to adjust the player's alignment 2 points towards good. Now, there is an inbuilt function for doing just that, so you will need to add one line of code with the proper input parameters. If you're feeling up to it, you can pause the video now and try and write it yourself. Okay, so welcome back. Don't worry if you didn't manage to solve this yourself. The adjust alignment function uses some concepts which we haven't covered yet, but we're going to look at them now. So what we wanted to do was to adjust the player's alignment, so we're going to search up alignment in the function tab, and we see a few functions come up here. The one that we're after is the adjust alignment function. So we can double click to insert this function straight into our code. If we click on the function name, as always, we will be able to see the definition and any documentation in the bottom pane here. We can see that this function takes 4 input parameters, one of which is optional, and this function returns void or nothing, so it doesn't return anything. Because the return type is void, we don't have to worry about capturing the output, so we just execute the function with the right inputs, and that will produce the desired result for us. So let's take a closer look at the input parameters here. The first parameter is object OSubject. Now, this is where it might get tricky if you haven't encountered objects before. Objects are a data type, like we saw with our integers or strings, which we encountered before. But unlike those primitive types, objects are a little bit more complex. So an integer, for example, is just a number. That's all it can ever be. A string can be a letter or a sentence, but ultimately it's just a sequence of characters. These are simple to implement and quite simple to understand. Objects function a little bit differently, so let's go through that in a little bit more detail. I think for now it might help to think of an object as anything that we can select within the editor. So if you can right click on something and choose properties, there's a very good chance that you're looking at an object. So our merchant, our aux, and even our 2 little forest exits that we made in the very first video, they're all objects. Additionally, your player, or all of the players if you're building a multiplayer server, also count as objects. So why do we need them, and why would we want to use them in our code? So first of all, almost every script that you will write will have to interact with the world in some way. And that most likely means that your code will need to make a reference to some of the entities, some of the things that exist in the world. So in this example, our function doesn't know yet whose alignment it has to change. Are we trying to change the alignment of our merchant, of our aux, of the gate? It might be simple to assume that alignment shifts will always happen to the player, but what if it's a multiplayer server? How do we figure out which player is actually participating in the conversation and not shift the alignment of some random player or every player that's currently playing? So we can use objects to identify a specific entity in the world, and I'm going to talk about how we do this in a little while. So secondly, objects are, as mentioned, much more complex than the primitive data types like integers or strings. Objects are essentially a representation of the entire entity you're describing in the code. So if you find your NPC object, let's say our merchant, you'd be able to extract any data that appears in that merchant's property tab. So age, alignment, name, spell list, and so on and so forth. So that's a lot of information, and we can't store all of that information inside a simple integer or a string. In fact, objects will typically use these more primitive types inside themselves to represent more basic data. So for example, our NPC object, our merchant, might have an integer variable inside to represent the merchant's age, and maybe a string variable to represent the merchant's name, and probably many more. So if we continue with our analogy from the previous scripting lecture, so if the variable is like a box for storing data inside, an object can be thought of as a big shelf full of different but related boxes that each represent a specific aspect or attribute of that object. Our object data type stores all the relevant data it needs about a certain entity. Now, this explanation is fairly simplistic and not 100% technically accurate, but it should help in understanding the type of variables that we are working with a little bit further down the line. As we encounter more objects in our scripts, we will get a clearer understanding of what objects are and how we can work with them. So for now, the function is requesting an input of the type object, which it is calling oSubject. That's just the name for that object variable. The oSubject is going to be the entity that we are applying this alignment shift to. Since we want to apply the alignment shift to our player, we need to figure out how to retrieve the object that represents the player. Thankfully, there are multiple ways we can do this. Because the script runs as part of a conversation, the easiest way is to dig down into the conversation data and find our PC, our player character, from there. We have a handy helper function for this. It's called getPCSpeaker. This function first finds which conversation the script is part of, so this is going to be our merchant's conversation in this case, and then finds out who the player speaker is that is currently involved in that conversation. So let's declare our first variable. To keep in line with convention, I'm going to use the same variable names as in the function signature. So object oSubject equals getPCSpeaker. Fairly straightforward. Okay, second variable for the function, second input parameter, is the integer n alignment. If you recall from the first scripting lecture, we can see that this value has a number of constants for us to use instead of just standard integers. So we can set this integer, this whole number, as follows. Int n alignment equals, all caps, alignment underscore good. This means that the alignment shift we are trying to move towards is alignment good. Okay, next is the integer n shift. This is simply the size or magnitude of our shift. As discussed last time, we want to move the alignment by 2 points. So this isn't a huge shift, but it's not bad for a second request. So here we can just add int n shift equals 2. So lastly, we see that the final parameter is optional. since a default value is already set in the signature. The first parameter decides, the final parameter here decides whether it is our player that receives the alignment shift, or if all the associated henchmen and companions also get the same alignment shift. For me personally, it doesn't make sense that companions gain any sort of alignment impact from the player's choice, so I'm actually going to override this default and set the last parameter explicitly to false. So that means only our player will gain the benefit of choosing this option if they decide to do so. So here we can declare this as follows: int b all party members equals false. Do note that booleans are represented by int, integer data types in NW script, with 0 being false and 1 being true. Almost all modern programming languages have a distinct separate data type for representing booleans. Alright, so now that we've declared our 4 parameters, we can simply slot them into place like so. Adjust alignment, open brackets, O subject, comma, N alignment, comma, N shift, comma, B all party members, close brackets, and a semicolon. Now, some among you might have noticed that I am explicitly setting these variables before running the adjust alignment function. I do not need to do this. In fact, I could replace these 5 lines of code with one statement: adjust alignment, open brackets, get PC speaker, comma, alignment good, comma, 2, comma, false, close brackets, semicolon. This will run in exactly the same way because basically we're just retrieving all the same variables, all the same values, but we're not declaring them explicitly. I do find, however, that if you are new to scripting, it helps to write everything out in more detail. It will be easier to read later on and find and fix any bugs that occur. However, if you are feeling confident or if you prefer the shorter way of writing it, do go ahead. It doesn't actually make any difference in terms of how well the script performs. Either way, we can save the script. For now, we can save this as s underscore, then the name of the NPC, then another underscore, and then qr0. You'll see why I'm using this convention in just a moment, as we will be coming back to the script shortly. So now the alignment shift should work. You can test it out if you like. Just make sure that the script we've just made is attached to the actions taken of the appropriate conversation node. I'm just going to go ahead with the next part without testing just yet, and then we'll do a test at the end. So our second challenge from last week was that the NPC gives us a variable reward. The default reward, if you recall, is 50 gold. Additionally, our player can haggle to receive a reward of 75 gold or 60 gold, depending on their persuasion roll. Finally, the player can refuse the reward altogether. So in total, we have 4 different reward options, which are 0, 50, 60, and 75. What we would like to do is for the NPC to remember which reward option was offered to us. So for this, we're going to need to persist some of the data from the conversation. Now, we haven't really done this before in our scripts. If you recall, our aux script runs on heartbeat, which is every 6 seconds. And it generates a new random number each time and then does its animation depending on that number. But the whole function does not return any information, and it does not save any information. Essentially, it either triggers the animation or it doesn't, and each time the script runs again, it does so with brand new information. So it generates a new random number and tries to do that logic again. Here instead, we would like the reward to be persisted. It would be of little use if every time we spoke to our merchant we could re-haggle for better pay, or if she didn't remember what she offered us in the first place. So luckily we have an easy way of doing this using local variables. Local variables are our way of ensuring a piece of data we want is added to our object to be kept safe until we need it again. This means that the data continues to exist even after the script that originally created or modified that data has finished running. Alright, so let's think about the behavior that we want to set for the reward. Firstly, we know that our default reward is 50. This will be the case if the player doesn't ask about the reward at all, or if they get told about the reward and choose not to haggle. So out of our 5 conversation paths, 2 will lead to the default reward of 50. We may have more later on. For me, therefore, it makes sense to set this as early as possible in the conversation. So for now, I'm going to add a small script to the very first sentence our player hears. As usual, we can go to the Actions Taken tab and click on Edit to create a new script. Here, we'd like to use a function to set a local variable for the reward. Setting a local variable behind the scenes is pretty much like declaring a normal variable. We're putting a value inside a named box. However, setting and retrieving a local variable also requires a reference to the object that is going to hold on to that variable for us. Since this is part of the NPC's conversation, the merchant is going to be the object that is storing the variable. So we can use the following function, set local int. If we observe the signature, we see that we're taking 3 parameters here. Firstly, we need an object in which this data is going to be saved. As discussed, we want to save the quest reward to the merchant. We could save it to the player, and there are good reasons for doing this, and which I'll explain at the end. We could even save it to the aux. That wouldn't make much sense, but the script would function in the same way. The point is, we need to ensure some object is holding onto this data for us, and since it's the merchant's quest, for me it makes sense that the merchant object is the one that's holding onto this data. So there are various ways to retrieve the merchant object, but we're going to go with a little shortcut here. Since the merchant is also the owner of the conversation, if you remember from last video, the merchant is the owner of the conversation that we're currently in, we can simply write object_self in this field, and the script will understand that we would like to set this local variable on the same object as the owner of the conversation. That's our merchant NPC. If this is still a bit confusing for now, don't worry. Getting your head around objects is one of the first big hurdles of programming. So with continued practice, it will become easier and much clearer. Okay, our second parameter is the variable name that we would like to use, and that's going to be a string. Since we're trying to represent the quest reward, let's just call it quest reward. Finally, the third parameter is the actual value of the reward. So by default, we will set this to 50. So let's put that in there. Perfect. Now, when this script runs, our NPC will store an additional integer inside itself called quest reward with the value of 50. So let's save this. Again, the convention s_NPC name _ QR50. The QR stands for quest reward, and you might now see why we called our first script that. So speaking of which, we're going to go back into that first script that we made about 5 minutes ago, and it's at this line in the conversation that our alignment shift towards good by 2 points. But also, what we'd like to do is refuse the quest reward. Since the original script runs at the beginning of the conversation, we know that by this point, the quest reward is set to 50 already. A variable, as a rule, can only store a single value inside it. So if we write something else to that same variable, the original value will get overwritten. So again, we can call our setLocalInt function. We're still referring to object self for the merchant. and the variable quest reward, but now we're setting the value to 0. It's really important here that quest reward is spelled the exact same way in each one of these scripts, else it will think there are multiple variables. And that includes a upper and lower case, obviously things like indentation, underscores, whatever else, it has to be spelled the exact same way. Okay, so now we've covered 2 of our options. Let's set the remaining 2, which is 60 and 75. If you recall, these are the results when the PC tries to haggle for a greater reward. So it would make sense to create those adjustments when the NPC responds with either success or failure. So let's find those nodes now. On this success node, we can call our set local int once more. Object self, quest reward, set that to 75 and save. And then we can go to the failure nodes, set local int, object self, quest reward, 60. And save that as well. Perfect. Okay, so that was quite a few scripts. Hopefully you understand the flow of that conversation a little bit better now, and how we are changing that variable after it is initially set at the start of the conversation. So now that we've set the variable, we're going to take a look at some of the cool things that we can actually do with it. So let's first navigate to the node where all the paths converge. That is the NPC thanking the player for taking on the quest. If you remember, we will always hit this node in the conversation regardless of the player's choices. So this seems like a good place to sort of clean up and make sure that everything comes together. This is also the node where our journal entry is being assigned to the player's quest log. So here we're going to do a few things. First of all, we're going to create another local variable. This one's going to be a boolean, and you will see why we create it in a sec. This is a flag, as it's known in common terms. A flag is just an internal indicator to tell us whether some action has been done or not. So the flag that we'd like to add here is for the player actually accepting the quest. If the player interrupts the conversation at any point before this node runs, and they can do that by walking away, for example, we know they haven't actually committed to the quest yet. However, by the time we get to this stage in the conversation, we know that the player has all the background information and they've agreed to take on the quest. So let's set the following flag. Set local int. Again, we're going to do that on object self. We're going to do that on our merchant. And let's call this a quest accepted. And then we're going to set the value of this to true. Again, this is technically a boolean, which is true or false, but we do not have a dedicated boolean type in NW script, so we're going to have to use an integer for that. So now that's done, let's retrieve our quest reward variable and do some stuff with it. First, let's fetch the value. Retrieving the value is simple. Let's create a new integer variable to store the value of our quest reward. We can do this as follows. Int quest reward. So if you remember, we are creating here an integer of that's called quest reward. And we're going to set that equal to get local int. So the two parameters that we need are the object that's storing our quest reward and the variable name itself, which is just quest reward. So here we're retrieving the value from the object itself that's stored under the name questReward, and we're putting it into a temporary integer variable called questReward. Again, we don't have to do this. We can use the value directly, but this makes our code slightly more readable, slightly less challenging to read and debug later on. So secondly, let's convert this value into a string. You'll see why we do this in a minute, but recall that string variables can only accept string values. For this, we're going to be using an inbuilt function to cast. Casting simply means that we're converting a piece of data from one type to another. Here, we're converting the integer questReward into its text equivalent. So we can do this as follows: string questReward string equals int to string, and then in brackets questReward. So to the untrained eye, these two variables will look exactly the same, but because we know about how data types work, we understand that the number 75 and the string 75 are two very different things. So lastly, we're going to use another very cool feature of the toolset, which is called a custom token. A token is a string that can be used in many places once it's set. So what we're going to do here is create a dynamic piece of text that tells us how much our questReward is and then adds it to our quest log. So to do this, we're going to use another built-in function called setCustomToken. SetCustomToken takes in two parameters. Firstly, an integer that we use to identify the token. This can be any value that you like, up to about, I think, roughly 2 million. And the second parameter is the actual string that the token will contain. So let's write out this function. Set custom token, open brackets, 2000, that's going to be the ID of my token. And then for the second parameter, let's put in open quotes, I will receive a reward of space, close quotes, plus questReward string, plus open quotes again, space, gold for completing this mission, full stop, close quotes, close brackets, semicolon. Do note that I'm using the ID 2000 here because some of the early numbers of tokens are reserved for internal tokens for the engine. This doesn't matter much for our purposes, but just as good practice and to avoid overlapping with any reserved IDs, we can safely start at 2000 and work our way up from there. So in the second part of this function call, you can see that I'm actually using 3 different strings as one input parameter. This is possible because of something called string concatenation. Concatenation means that I can join together any number of smaller strings using these plus signs to create one long string. So here I'm using the start of the sentence, I will receive a reward of, followed by whatever questReward we have, followed by the end of the sentence, gold for completing this mission. This means that our questReward is slotted into the sentence dynamically based on the outcome of the player's conversation. In this way, we can produce 4 different sentences for each one of the different reward values using one line of code, which I think is pretty cool. So let's save and exit this and head over to the journal editor to put in our newly created token. Because custom tokens can be used almost anywhere else once set, the journal is one of the most common usages for them. We can create a dynamic entry for our journal with very little code, as we will see now. So to slot the token in, let's simply head over to our first entry here and add a triangle brackets custom 2000 towards the end of the sentence here. If you recall, 2000 was the ID of our token. Obviously, if you used a different ID, then use that number here instead of 2000. And that's it. So let's test it out and see our improvements. I'm going to go through the dialogue here, and as soon as we get the quest, we can head to our quest log, and we should see our new sentence has been added to the log with the exact amount of gold that the quest reward specified. And that is pretty cool. We do still have a couple of smaller issues here. First of all, the sentence, I will receive a reward of 0 gold coins for completing this mission, seems a little weird. Secondly, we can continue chatting to the merchant and set different rewards after the quest has been accepted. A player might try to get around or exploit this, for example, by firstly taking the selfless option of forfeiting the reward, in which they get the 2-point alignment boost, and then speaking to the NPC again to try and get the 75 gold reward. That way they get both the alignment shift and the money, and we really don't want them to be able to do that. So a few last minute fixes, and then we will wrap this video up. So first of all, let's make our token a little bit nicer. We're going to go back over to the script where we're setting it, and let's put in a condition. If the player is getting some gold coins for this, that's any value of gold coins that's higher than 0, we can display our usual sentence, and that will say, I will get a reward of 50 coins or 60 coins or whatever it might be. If the player is forfeiting the reward, we can display text to that effect instead. So here's how we're going to do it. If you recall, every time we want to branch in our code, the simplest thing to do is to use an if statement. However, unlike the previous if statement that we did in the Oxus script, where we do the actions if the condition is true, or we don't do anything if the condition is false, here we want to set the token to something, regardless of if that condition is true or false. So we will need to create some value for the token. So let's first test for our condition with if, open brackets, quest reward is greater than 0. That is, we want to determine if our quest rewards, and that's the integer, not the string, is greater than 0. If it is, we're going to display our usual sentence, so let's just paste that bit of code into the block here. Awesome. But what do we do if the quest reward is 0? Okay, so let's display a different sentence. For this, we're going to use the if's fellow statement called else. Else just helps us direct the flow of logic a little bit better. The way it works is, if the condition that we're testing for is true, then we will execute the if part of the statement. Otherwise, we will execute the else part of the statement. That way, something gets added regardless. So straight after our if block concludes, let's add else, open a new block, and let's set the custom token again. So set custom token, open brackets, 2000 is the same one. And let's just put in some other text here. Let's say, I have chosen to forfeit the reward in order to help out a person in need. And that should be fine. Semicolon, close our code block there. So great, now our statement is going to look a little bit better in the quest log. We're going to have either the a detailed description of how much gold we're getting, or we're going to have this unique bit of text if we're forfeiting the reward. Now, one other little thing that we want to fix up before we sign off. So if you remember this boolean that we made at the very top of the script, we're going to use it now to fix the flow of conversation in the same way as we just did with this if-else statement. If the player has already accepted the quest, we want them to see a different bit of dialogue from the NPC. No point running through that exposition again and being able to change the reward that's being offered by the NPC. In other words, you can only pick up the quest once, so be careful with your conversation choices. For now, we're going to navigate all the way back to our root node in the conversation editor and press add. Here, we'd like to add the conversation option for further interactions with the NPC. So for now, we can keep it simple. Let's say something along the lines of, hey, have you found my ingots yet? To which the player can respond, no, I'm still looking. This will be the default bit of conversation displayed if the player already has the quest acceptance flag on. So now, if you recall from last time, conversation options are chosen for the NPC based on the first conversation option, for which text appears when is true. Okay, let's say that again slowly. The conversation options are chosen for the NPC in sequential order, and it will play whichever one has this text appears when condition as being true. Now, if this does not have a condition, then it is always true by default. So whatever conversation is at the top, that was the one that's going to get played. So there are various ways we can switch between these two paths. I will demonstrate one of them here, but there's at least one other way in which you can achieve the same result. I will leave that up to you to investigate if you want to take that on as a little challenge. So let's move our newly created conversation option on top of our existing tree. So this will be the first conversation option that the editor looks at. Without a condition in this node, it's always true and it's always just going to play this. So we need to create a little conditional here. So sometimes we don't want to play this option. I think we've already done quite a lot of unfamiliar scripting today, so I think let's take it easy for this last part. We're going to use the script wizard for this. So head on over to the little wizard hat. Now we want to check for the local variable that stores the value of quest accepted. So remember, quest accepted is only being set at the end. It's being set to true once the player actually accepts the quest. Because it's not being set or declared anywhere else, it will be 0 or false by default. So even though we're testing this for this variable, before the conversation ever even sets it or creates it, it has a default value of 0. So we are only setting it to true when we actually accept the quest. So let's check the local variable box and move on. The condition we'd like to check for is that our integer quest accepted is equal to 1. So remember, 0 represents false and 1 represents true. So here we're checking if quest accepted is true. Okay, let's add this next and save the script. So now we need to open it up for a quick edit. As you might notice, the presence of the local variable here is getting checked on the PC speaker rather than our NPC. Now, I'm pretty sure the reason that Neverwinter Nights does this by default is because they have multiplayer in mind from the get-go. So if we set these variables on the PC speaker, then every player that interacts with this quest in a multiplayer world will have their own flags, which is the way that it should be. We don't want another player overwriting our reward of 75 gold with their reward of 50 gold. So if we're setting these values on the PC speaker, then quest reward and quest accepted values would be unique to each player. The downside of this, however, is that we need to come up with more creative names. So quest reward can now refer to any quest that our player picks up. So we need to specify something like quest reward underscore NPC name. Secondly, we're storing a ton of information all on the player side, barely anything on the NPC, but that is the way that we would have to get around it for multiplayer. Now, ignore all of that just now because I am writing this module with single player in mind only. So we can store our variables wherever we like. We can store them on the NPC, we can store them on the player, we can store them anywhere because the player is the only one that is going to be setting and unsetting these variables. This makes it much, much simpler for us since each object in the world is largely responsible for their own quest data. However, if you would like to later convert to multiplayer, then we will talk about how to properly store all the variables on each individual PC. I'll maybe do a separate video on multiplayer and just some of the difficulties you might encounter doing that. For now, because we're storing on the merchant, we're going to change this get PC speaker again to object self, which is our conversation owner, which is our merchant, and done. So we can now breathe out, have a cup of tea, and let us test this. I'm not going to go through all the variations in my testing, but I will take the most interesting option, the one that's forfeiting the reward. If we've done everything correctly, we should see the alignment shift, followed by the unique reward text in our request journal. And the second time we speak to the NPC after accepting the quest, we should have the have you done it yet dialogue instead of the exposition, meaning we can't set the reward or get the alignment shift for a second time. And I think this has now turned out to be a rather lengthy video, so we're going to conclude it here. Well done if you made it to the end of the video. We've covered a ton of stuff today. We've got had objects and local variables, custom tokens, and then we took a further look into how conditionals work. That's your if-else. As always, if you found any of this tricky or confusing, please let me know in the comments and I will do my best to respond fairly promptly. So next time we'll get started on building out our little goblin camp and learn about tiling, placeables, and various other sort of scene setting apparatus that is available to us. Until then, thank you for watching and I will see you again soon.